When designing a fish trap system with multiple motors and electrical components, it's crucial to implement effective grounding techniques to prevent stray current from flowing through the tanks and to ensure that a shorted pump will clear the overcurrent device, preventing the water from becoming energized. Here's a breakdown of recommended grounding practices. Firstly, bonding and grounding are essential. All metal components of the system should be bonded to a common grounding busbar. This busbar should then be connected to the system's main grounding electrode. It's important to use Underwriters Laboratories listed grounding electrode system to ensure compliance with safety standards. Secondly, consider the use of isolation transformers. Installing an isolation transformer between the electrical distribution system and the fish trap can isolate the fish trap system from ground current, effectively preventing stray current from flowing through the tanks. Thirdly, ground fault circuit interrupters, or GFCIs, are crucial for safety. GFCIs should be installed for all electrical outlets and equipment within the fish trap system. These devices detect even small amounts of current leakage and will trip, preventing electric shock hazards for personnel and minimizing potential harm to aquatic life. Fourthly, waterproof grounding is a must. All grounding connections must be waterproof to prevent water from entering the electrical system. Use waterproof connectors, sealants, and conduit fittings to achieve this. Fifthly, bonding of metal tanks is important. All metal tanks in the system should be bonded together to create an equipotential plane. This ensures that all tanks are at the same electrical potential, preventing stray current from flowing through the water between the tanks. Sixthly, overcurrent protection is critical. Size overcurrent devices, such as circuit breakers or fuses, appropriately for the electrical equipment in the system. These devices should clear if a pump shorts, preventing the water from becoming energized and potentially harming the fish. Seventhly, regular inspection and maintenance are vital. Regularly inspect the grounding system to ensure it remains intact and effective. Measure ground resistance periodically to verify that the grounding system is functioning properly. This ensures ongoing safety and compliance. For further information, refer to the White Paper Stray Current Mitigation in Fish Handling Facilities, a guide to best practices by the Electric Power Research Institute, or EPRI. Additionally, consult Institute of Electrical and Electronics Engineers Standard 1100-2019 recommended practice for powering and grounding electronic equipment. And also consult National Fire Protection Association 70, the National Electrical Code. Furthermore, consider the Electrical Construction and Maintenance article on electrical safety for fish handling facilities, accessible online. A well-designed grounding system is critical for a fish trap system. Grounding is not just about safety. It's also about protecting the electrical equipment and ensuring the long-term reliability of the system. The primary goal of grounding is to provide a low impedance path for fault current to return to the source. This low impedance path ensures that overcurrent protection devices, like circuit breakers and fuses, will operate quickly and effectively in the event of a ground fault. This rapid response minimizes the amount of time that the fault current flows, reducing the risk of damage to equipment and electrical shock hazards. An equipotential plane is created by bonding together all conductive surfaces within a defined area. In the context of a fish trap system, this means bonding together all metal tanks, piping, and other conductive components that could potentially become energized. The purpose of the equipotential plane is to minimize voltage differences between these conductive surfaces. This is important because even small voltage differences can drive stray current through the water, potentially harming the fish. By bonding all conductive surfaces together, you ensure that they are all at the same electrical potential, eliminating the driving force for stray current. Isolation transformers provide electrical isolation between the power source and the load. They do this by using separate primary and secondary windings that are not electrically connected. This isolation prevents ground current from flowing from the power source to the load, which is particularly important in sensitive applications like fish handling facilities. Isolation transformers can significantly reduce the risk of stray current and electrical shock hazards. Ground fault circuit interrupters, or GFCIs, are designed to detect even small amounts of current leakage to ground. They work by monitoring the current flowing in the hot and neutral conductors of a circuit. If there is a difference of 5 milliamps or more between these currents, the GFCI will trip, interrupting the circuit and preventing electrical shock. GFCIs are particularly effective at protecting against accidental contact with energized equipment or wiring. When selecting overcurrent protection devices, it's important to consider the specific characteristics of the equipment being protected. For example, motors typically have high inrush currents when they start, so it's important to select a circuit breaker or fuse that can handle this inrush current without tripping unnecessarily. It's also important to coordinate the overcurrent protection devices so that the device closest to the fault will trip first, minimizing the impact on the rest of the system. Regular inspection and maintenance are essential for ensuring the continued effectiveness of the grounding system. Inspection should include a visual examination of all grounding connections to ensure that they are tight and corrosion-free. Ground resistance measurement should be taken periodically to verify that the grounding system is providing a low impedance path to ground. Any problems identified during inspections should be corrected promptly. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. Article 250 of the NEC covers grounding and bonding requirements for all types of electrical systems, including those used in fish handling facilities. It's important to be familiar with the NEC requirements and to ensure that the grounding system is installed in accordance with these requirements. Proper grounding is a critical component of electrical safety in fish trap systems. By following these grounding recommendations and adhering to applicable codes and standards, you can minimize the risk of stray current, electrical shock hazards, and equipment damage. This will help to ensure the safety of personnel and the well-being of aquatic life. Additionally, consider consulting with a qualified electrical engineer to design and install the grounding system for the fish trap system. An electrical engineer can provide expert guidance on selecting the appropriate grounding methods and equipment for the specific application. They can also perform calculations to ensure that the grounding system meets all applicable codes and standards. A properly designed and installed grounding system is a worthwhile investment that can provide long-term safety and reliability for the fish trap system. Effective grounding requires more than just connecting wires to ground rods. It involves a comprehensive approach that considers all aspects of the electrical system, including bonding, isolation, ground fault protection, and overcurrent protection. By paying attention to these details, you can create a safe and reliable electrical system for the fish trap system. Furthermore, documentation of the grounding system is essential. Keep records of all grounding system components, including the size and type of grounding conductors, the location of grounding electrodes, and the results of ground resistance measurements. This documentation can be helpful for troubleshooting problems and for verifying that the grounding system meets applicable codes and standards. In addition to the recommendations already discussed, there are a few other best practices that can further enhance the effectiveness of the grounding system. Firstly, use dedicated grounding conductors. Avoid using the metal conduit or equipment enclosures as the sole grounding path. Instead, run a dedicated grounding conductor along with the circuit conductors. This provides a more reliable and lower impedance grounding path. Secondly, minimize the length of grounding conductors. The longer the grounding conductor, the higher its impedance. Therefore, it's important to keep grounding conductors as short as possible to minimize impedance and ensure effective grounding. Thirdly, use exothermic welding for grounding connections. Exothermic welding provides a permanent, low-resistance connection that is resistant to corrosion. This is particularly important for grounding connections that are exposed to moisture or other corrosive elements. Finally, consider using a grounding system analyzer to evaluate the performance of the grounding system. A grounding system analyzer can measure ground impedance, ground voltage, and other parameters that can help to identify potential problems with the grounding system. By implementing these best practices, you can further improve the effectiveness and reliability of the grounding system for the fish trap system. Remember that grounding is a continuous process. It's not enough to simply install a grounding system and forget about it. Regular inspection, maintenance, and testing are essential for ensuring that the grounding system continues to provide effective protection over time. Stay informed about the latest grounding technologies and best practices. The field of electrical engineering is constantly evolving, and new grounding technologies and techniques are being developed all the time. By staying informed about these developments, you can ensure that the grounding system for the fish trap system is using the most effective and up-to-date methods. In conclusion, implementing a comprehensive grounding system is crucial for ensuring the safety and reliability of a fish trap system. By following the recommendations outlined and paying attention to the details of grounding system design, installation, and maintenance, it's possible to minimize the risk of stray current, electrical shock hazards, and equipment damage, protecting personnel, aquatic life, and the integrity of the equipment.